In this film, we're going to derive or find the demand function for labor. To do that, we need some functions. We start with the marginal revenue product. That's the value of the marginal product. So we have the marginal product that's defined as the production change that we will get from the last or the next employed unit of labor. And we multiply that one with the marginal revenue we receive when we sell that one on the market for the good that we are producing. The marginal revenue product will have a scenario where it increases up to its maximum and then decreases. If we have a scenario where we have this marginal diminishing returns for the production factor. We also need the average revenue product, which is the same thing but on average. So now we calculate an average product, which is the total production divided by the number of labor that the firm is using, and we multiply that average production with the money we're receiving when we're selling each of them on the market. And that one will also be increasing to its maximum and then decreasing. And when we look at the marginal and the average, we know from the mathematical part that to get an average to increase, you have to add the marginal value that is higher than the average. And to get an average to decrease, you have to add the marginal value that is less than the average. So therefore, it's quite easy to understand as to get this one, the green one, the average revenue product, to increase, then the marginal value has to be higher for each labor unit. And to get this one to decrease, we have to add marginals that is less than the average, so therefore we have to have a marginal that is below the average revenue product. If we make the assumption that the company is buying labor on the competitive market, or that they have engaged themselves into contracts, so they are price takers anyhow, then they are facing different wage rates. So if we start with a rather higher wage rate, WA, we see here that that one will be the marginal factor cost, or the marginal cost for buying labor. And the marginal condition that we always try to fulfill is that the marginal cost should be equal to the marginal revenue. So in this case, we got the marginal cost for the factors in buying, marginal factor cost, which is a horizontal line given by the market price for the labor. And here we got some expression for marginal revenue. So therefore we see here that we have the marginal factor cost equal to the marginal revenue product at two positions. There's to the left one and to the right one. And if we start thinking of it, we see that each unit up to this one brings a revenue that is less than its cost. So this one will be some kind of a profit loss or maximum or something like that. So therefore, out of these two, this one will be the least bad one in this scenario, actually. Let's compare that one with the revenues that we can receive. We start by calculating the total variable cost. The total variable cost, as usual, defined as the wage rate times the labor units that we are buying. So in this case, WA times LA. So this area, this rectangle there, that is the total variable cost. And that one should be compared to the total revenues that we receive. And to get the total revenues, we need to use the average revenue product. Average revenue product is defined. In this case, I made the assumption that we are selling the good Q at a perfect competition market. So they are price takers anyhow at the Q market. So they are facing a given market price, PQ. So therefore, we got PQ times the average product. That's the definition for the average revenue product. And then we multiply that one with the labor units that we are buying. In this case, it could be LA. So therefore, we got LA times P times PQ times Q divided by LA. So we see we got the L times this expression divided by L. So those two cancels out. So what we are left with is PQ times Q, which we know is the standard definition for the total revenues. So therefore, we see here that the average revenue product for LA units is given by the green function, the average revenue function at LA. So therefore, the total revenues this company would receive if they were to buy LA units were this rectangular, which is much smaller than the total variable cost, which is this rectangular. So therefore, this company wouldn't even cover its total variable costs. And that we know from the supply side that this is something that they are not interested in, because they are not even covering all of their variable costs. And then they also have to pay the fixed cost. So we have to look at another wage rate. So we take a much lower one, let's say WC. The modular condition, modular factor cost equal to modular revenue product, gives us that the company would be willing to buy LC units of labor, and the revenue that we receive will be average revenue product at LC. So the total variable, the total revenues will be this rectangular, and the total variable cost will be WC times LC, which is this rectangular there. So in this case, we see that the total revenues are much greater or larger than the total variable cost. So therefore, we will have a positive difference if we deduct the total variable cost from the total revenues, which could be used to pay for the fixed cost and perhaps even a positive profit. The highest wage rate that this company in this scenario is willing to pay is WB, because here we see that WB times LB, that's the total variable cost for LB units, will be exactly the same quantity or money as the total revenues that we will have from LB. So average revenue product times LB will be equal to the total variable cost. So in this case, we see that the total variable cost is identical to the total revenues, and therefore we will have a total profit of a loss with the fixed costs, which is, if you remember from the supply side, so when we derived the supply function, that was the shutdown point. So they were not interested in selling to a lower price than that one. This is the same position. But now we're looking at buying the variable production factor. So therefore, it's quite easy to understand that the demand function will be given by the modular revenue product based on this modular condition, modular revenue product equal to modular factor cost, and from the position where it's intersected by the average revenue product, and then downwards down to the L-axis down there, because we don't assume that we will have negative wage rates. So therefore, the demand function for a production factor is given by the modular revenue product from the average revenue product and downwards.